This is problem number 6 for assessment number 2. In this problem it says solve for the angle theta where 0 is less than or equal to theta less than or equal to 2 pi. And you'll see we have sine of 2 theta minus root 2 cosine theta equals 0. Now my goal in a problem like this is I want to try and make the trig functions be the same. So I'm going to try to either make sine be cosine or cosine be sine. So I'm going to start looking through the formulas to see what formulas can I use. And I'm going to look for double angle, especially if I see that I have 2 theta. That's obviously double angle. It kind of gives it away. So I look at the double angle formulas, and I see sine 2 theta equals 2 sine theta cosine theta. So I'm going to use 2 sine theta cosine theta and replace it in here for sine 2 theta. So I know that sine 2 theta equals 2 sine theta cosine theta. So I replace that in here and say 2 sine theta cosine theta minus root 2 cosine theta equals 0. Now I want to reiterate here that I had a double angle here, which usually leads you to believe that you're going to double this this domain up here. But because I switch from double angle to just a single angle, at the end when we find our angle, we don't have to double this because I'm ending just with theta. If I end with like 2 theta, I need to double this this domain. Let's go ahead and take a look what happened here. So I plugged in 2 sine theta cosine theta. I also have a cosine theta here. This, like, as soon as I see that I have cosine theta in each of those, I think I need to factor that out because I can probably use the zero product property because this all equals 0. So I'm going to say cosine theta, factor it out, and I end up with 2 sine theta minus root 2 equals 0. So I have a product, it equals 0, zero product property, so cosine 0, or cosine theta equals 0, or 2 sine theta minus root 2 equals 0. Add the root 2 over and divide by 2, and I end up with sine theta equals root 2 over 2. Added the root 2 over, divided by 2. That's how we got root 2 over 2. So I have cosine theta equals 0, or sine theta equals root 2 over 2. When does cosine theta equal 0? Well, if I look at the unit circle, cosine is 0 at pi over 2 and 3 pi over 2. So I'm going to go ahead and write down pi over 2 here. So pi over 2 and 3 pi over 2. And then when is sine theta root 2 over 2? Well, sine is positive in quadrants 1 and 2. And sine is root 2 over 2 at pi over 4 and at 3 pi over 4. So that means that I have pi over 4 and 3 pi over 4 as well. So this is what theta equals. At this point where I'm essentially doing the inverse of cosine and inverse of sine to find these, I'm saying theta equals these angles. Now because I only had theta at the end, this goes back to what I was saying at the beginning. We started with 2 theta, but when we're evaluating this at the end, we're only evaluating theta. If this were 2 theta, I would double this. But I can't double this because I'm just having theta here, and theta is what's in the domain. So I hope that makes sense. If this were 2 theta, you would double this, this domain. But because it's only theta, we're just going to leave it as is. And these are the 4 answers for our problem.